We are now going to correct the problems that you completed on your own at the bottom of the textbook, page 13. Problem 3. First set of problems, you had to find the values of the power. So problem 3, we have 6 to the third power. That means 6 times 6 times 6. It gives us an answer of 216. Number 4 is 81. Number 5 is also 81. And number 6 is 324. For the next 4 problems, you had to just determine whether that number was a perfect square or not. Meaning, can I multiply one number by itself and get that number as an answer? Well, with 25, the answer is yes. I can multiply 5 times 5, and that gives me the answer 25. Number 8, the number 2 is not a perfect square number. If I multiply 1 times 1, I get 1, and 2 times 2 is 4. So there's no way to multiply 2 by multiplying a whole number by itself and getting the answer of 2. Number 9, 99 is also not a perfect square. If I multiply 9 times 9, I get 81, and 10 times 10 is 100. So there is no way to multiply a number by itself and get 99 as the answer. And number 10, 100, the answer is yes. If I multiply 10 by 10, I get the answer of 100, so that means 100 is an example of a perfect square number. Okay, let's take a look now at example 4. This is how can I apply perfect squares to something in real life. Anytime we're talking about area, we're really just talking about one side of the shape, or it would be a square in this case, and multiplying it by itself. Area is always the side squared, or S times S for side. So let's take a look at example 4. It says a Monopoly game board is a square with a side length of 20 inches. What is the area? So if we know that one side is 20 inches, I just need to take the side length and square it. So 20 to the second power means 20 times 20, and I get the answer of 400. Okay, let's do this on your own problem together. We have a stop ahead sign, and it is a square that is 24 by 24. If I multiply 24 times 24, I'm going to get the answer of 576 inches squared. Okay, it is time for us now to begin the activities. And I know that I'm to the activities because we have our essential question here. How can you use repeated factors in real life situations? And repeated factors are just a way to think of exponents. So remember, our purpose for today is to identify and compute math problems with exponents. So what I'd like for you to do is please take a look at activity 1. Once again, we're to the activities, so it's in your textbook and your workbook. Please open up your workbook to page 7 and your textbook to page 10. I'd like for you to please read the directions to yourself as I read them aloud. Work with a partner. Here is a St. Ives poem written by 2 students. Answer the questions to the poem. So please read this poem to yourself and then answer the questions at the bottom of the page. Now, because we're to the activities, we're to the parts of the lesson where you're going to work through them with a partner. Once you're done working through the activities, then we'll go over the answers together. Today, you are going to complete activity 1 and activity 2, and you can skip ahead after activity 2. Go ahead and skip ahead to the what is your answer on page 9 and complete question 4.